Okay, so hello everyone, and welcome to this session of Smart Industry. And we are going to talk about how to accelerate the twin transition in the manufacturing industry. Myself is Angelo Marguglio, and together with Ernö Kovacs, we are the co-chairs of the Smart Industry Mission Support Committee, and welcome you in this interesting session. The overall agenda, I would say the lineup of the speakers that we have today is really rich. We will start with Mr. Yves Paindaveine from the Digiconnect that will introduce the European context on how the manufacturing industry is really, I would say, promoting and putting in place how to work in the digital and green transition. Then we will have an introduction from the co-chairs of the Mission Support Committee on how these roadmaps activities also been impacting the FIWARE ecosystem. Then we will have a bunch of use cases from our community dealing with digital twin, smart factory scenarios, data space, and so on and so forth. I will introduce each of the speaker later today, so I don't want to mix it up, I would say, the timing of the agenda. So I will now hand over to Mr. Paindaveine. And as mentioned, is the head of sector of the Digital European Industry and Governance Unit within A4 of the Digiconnect. He's an engineering, so he's really obviously a technical background that has been working for many years on the digital agenda for Europe, and now is also involved, as mentioned, on several initiatives that are moving our approach, our European approach toward the next generation of digital European industry. So, Mr. Paindaveine, the floor is yours.
Many thanks, Angelo, and I will share now my screen to bring the presentation. And okay, while it is coming up. So good morning, everyone. Still time for the morning indeed, as we haven't had lunch yet. So as Angelo said, I'm in the European Commission in Digiconnect in a unit called the Digital Transformation of Industrial Ecosystems. And we are busy with a number of priority topics with which I would like to go with you through it, both from the point of view of the priorities of the Commission for the green and digital transitions, as well as of a bit of the funding program. One of the things that we have realized is that the crisis has actually hit the company very differently, and that we know. But if there is one good thing, is that it has actually accelerated the rate of adoption of digital technologies in Europe just over the last month of the crisis. So you could say, fine, we are on track, we have this acceleration, so why should we do more? And in fact, if we look at the digital transition, Europe is really home to manufacturing. So as Breton said, we want to have our industry to do more with industrial data, with its data. We want to achieve efficiency, productivity, high quality job in the EU. And this is one of the reasons why we want to accelerate this. And the digital transition is also necessary to enable the green transition to fully take place. So we have, in fact, now even set ambitious objective for 2030, in 10 years from now. So a digital decade is what the Commission wants to have, with very ambitious targets for the adoption of leading technologies such as AI, big data, and cloud, up to 75%. For SMEs, with a basic level of digitalization, getting from the 60% at which we are today to 90%. So that's really bringing everyone up, including the late adopter, and a bit of target also on the startup ecosystem to double the number of unicorns. If we look at it, and that's now from the technology perspective, we really want to increase the wealth of data. If you look at all the data that is around, it's currently providing 3% of GDP, and it could in 2025, we hope to already double this part. Now, looking at the technologies that exists, such as artificial intelligence, it is on the basis of data, analyzing what the data is providing, enabling to have this inference engine, and from which we can have optimization and better decision support. If we look at digital twins, so the way to virtualize physical asset, what we see here again, it's a design phase and a monitoring phase, but all of this is sensing the data, making sense with this, and being able to re-inject it in the production line. If I'm thinking of the edge computing, that is more and more the data is migrating closer to the machine thanks to the computing power that we have. And therefore, again, we are thinking here of making data available, created, adding value closer to the machine. All of these technologies, if you really see, are really converging towards a data economy. And one of the objectives that we want to achieve here is really that we have data spaces for trustworthy data sharing and reuse. And a data space would be not only an infrastructure, but will also be a governance. So that's a bit the kind of rationale that we have, and we proposed, along with other common European data spaces for health, for agriculture, and more for the private sector as well, to put in place these so that there would be the possibility for industry to really have trust in sharing their data with whomever they want, and they know that their intellectual property, they know that their availability of data, they know that the legality of sharing and reuse of the data is actually ensured from a technological perspective, but as well from a legal perspective. So it really is an infrastructure and a governance which goes both hands in hands. It makes sense to have a public intervention in a private sector. What we really want to achieve for the industrial and manufacturing sector here is building of industry commons, is really which are the parts that industry would not be able to develop by their own because they would not be able to capture the value which is created out of such an infrastructure. So that's really the kind of thinking that we have here behind these European data spaces. They will be part of the Digital European program. Data spaces, we're not starting from scratch. We have had already over the last year a number of early reference infrastructure, reference architecture, from IDS, Rami, and not to mention it, FIWARE as well. So this is really a point where we are building. In the past, we would have called that more the building of industrial data, business-to-business platform, and now we are moving on to the data spaces. From an architectural point of view, if we look at the different function that we want to see, and if we start from the data and cloud infrastructure, which is roughly a commodity nowadays, and the higher we go up, the higher we have added value in terms of manufacturing services. So you see, on top of such a cloud infrastructure, common element for data spaces, for example, an identification module. On top of this would live services, manufacturing data space, so for data sharing, for data reuse, along, and here the scenarios and the use case, I come in a moment to it. That would enable the development of further manufacturing application, and as well what the kind of things that we would like to develop is testing and experimentation facility, so that you are not only left alone when developing something, but you also have this possibility to test whether you are a supplier of digital innovation or a user, so that you have the necessary knowledge of what you will be here developing or using. And on top of this, we want to make sure that there will be a transfer and uptake, not only by leading innovative companies, but by a vast majority of the companies. And that comes with a number of technologies that we want to put in place along this development. Now, we have selected two kinds of scenarios. One is a scenario of a data spaces along the supply chain. Here, the idea is to have a very large number of different stakeholders, from suppliers to customer, to engineering, and with a proper collaboration between the different actors along the supply chain. It might be on the communication of bill of material, of opening order books. And you see this is really here testing, developing, starting from embryonic data space to enrich these. And then a second scenario, which is similar to some use cases you find also in other platforms, which is more a scenario of asset management, where here we would see a reduced amount of stakeholders to be involved. The manufacturer production site, who owns the machine, and that machine would provide its deep internal data to the machine supplier. So that means we have already two parties, with possibility of having either an integrator or a third-party service provider that helps to optimize the machine with all the cybersecurity constraints, with the real-time needs, with making sure that there is an availability of the 5.9 on the production site. And that gives a range of possibilities to deploy further a number of digital technologies, such as digital twins and smart contract. We have so far had a number of workshops together with you, together with manufacturing industry, together with suppliers of data platform. And really, the thing that we need to realize is we want to start small, but we want to scale fast. That's why we want to start from existing embryonic data spaces. The Digital Europe program, from which we are going to finance this, is not a research program. So I really stress it is not a research program. So we need to have solutions which really start with existing industry agreement, which help to build really a platform that provides value to the manufacturing industry right away. That's why there is a need to understand what is the customer value when these designs are put in place. There are standards like the administrative shell from RAMI, which is currently being standardized from a number of point of view, from the semantics, from the ontology, as well as from the functional point of view. And there is really here the need to select these existing standards and to implement them. So we know of connectors. You have also developed in FIWARE a number of those connectors. So here is, again, going through a proper inventory, a proper selection of those to see where they really make sense and where they really add value to the overall platform. Digital technology for a circular economy. I started the presentation saying we have a digital and green transition. We have both transition. Again, digital technology is there to help to build a circular economy, from blockchain to optimization, thanks to artificial intelligence. And here we have a big part of Horizon Europe in which we will be helping manufacturing industry and the process industry, thanks to public-private partnerships such as Made in Europe or Process for People, where we want to have industry to adopt the digital technologies in order to build a greener, a more circular economy. This is not to be underestimated. At the same time, in Horizon Europe, we need to build the next generation of the core digital technologies, not the technologies to be adopted maybe today in the manufacturing industry, but tomorrow. And that goes from microelectronics to photonics to AI to network to high performance computing, with a number of going beyond what is the current state of the art. That's a research program. So that's really here also when developing, let's say, the next generation of chip, because they will be more power efficient, or they will provide more real-time feature. It is also interesting here to have a number of use cases of the manufacturing industry to show and that to make sure that the core digital technologies will also be developed so that they serve a number of use cases in industry. And really, once we have gone through all of these funding programs, the Digital Europe program to build the capacity, the research program to make sure that we have the next generation innovation, we also need to make sure that all of the companies across Europe would have the possibility to acquire the digital innovation, that they have really the right technology for the right purpose, which corresponds to their needs. We're not talking here of a transfer of innovation to go to market. It's really finding the needs of SMEs and helping them to go through a digital transformation. And it's really a test before invest type of approach that we have. And through digital innovation hubs, what we want to do is to have hubs, almost one per every region of the EU, and at the same time making sure that we network them. And the value of the network is to provide the digital innovation and the competences to a hub which might not have that specific competence. So we really build it as a continent, as Europe, to make sure that we have the proper innovation infrastructure in place. And here we have the member states who have already nominated their first candidate. And therefore, this is something that we will be starting to build already as an infrastructure together with member states by the end of the year. And with this, I would like to close the talk. I have given you a bit of the feeling of where are the priorities from the technological point of view and from the policy point of view in terms of our green and digital priorities, that where we really want to go. And I must say, it's already good to see that FIWARE has developed a number of these priorities. And now the proof of the pudding is obviously in eating it. So Angelo, I give you back.
Mr. Paindaveine, really thanks for this thrilling introduction and overview on how at the European level you are really, I'd say, trying to create the convergence between several technological aspects and strategies that has been defined also in the recent years in order to give this transition toward the manufacturing data space. I will now start the second slot. This is somehow the positioning of the Smart Industry Mission Support Committee in this respect. I will co-share this slot with the Ernö Kovacs. As mentioned, he's the co-chair of the Mission Support Committee. Is a senior manager of the IoT research program in NEC Labs Europe. And is really, I would say, mainly focusing on aspects like context brokering and digital twin. So I will start with a short, somehow, transition from what Mr. Paindaveine has introduced today, and how we are also, I would say, tackling these challenges within the FIWARE community, and then I will hand over to Ernö for further details. So I want also to highlight two main aspects. I mean, the green and digital twin transition has a sort of twofold also time frame. I mean, we are going, I mean, the European have set this really challenging objective to become zero climate and zero X by 2050. But we already have also looking at specific strategies and implementation that will drive us toward this climatic change, but also take into account our manufacturing industry and our worker, our people. So it's not only a paradigm shift of how we have to turn our way to make business in our industries, but also how the people is at the center of our strategies. And we will see also in the different communication also, for instance, the one that has been mentioned regarding artificial intelligence transporting AI, for instance. Along this pathway, we are also looking at how we can really accelerate the path toward the twin transition. And this can be done through different level of regularity framework. And sorry, that I should arrive. Obviously, the aspect of the SMEs and how they, in terms of technology providers, but also technology adoption, is really driving the business in Europe. And here again, the role that a community like the one promoted by FIWARE is really addressing a lot is exactly trying to help them to drive their business through these challenges in terms of technology and business models that have to change to adapt to these new challenges. But the three main technological pillars that have been already mentioned are exactly the adoption and the nurturing of embryonic data space over real and concrete European data spaces, adopting AI, edge, and cloud solutions in order to foster the deployment of the already available technologies that are part of our ecosystem, but also in other open source community and other businesses. But they are already there. So the real challenge is how to deploy them to concretely create manufacturing data space and put them in operation. And now I want to hand over to Ernö that will introduce how we are tackling this aspect within the FIWARE community. And then, as mentioned, we will move towards some use cases that will present how this technology, as mentioned, are already there. So it's perfectly in line with the leitmotif of what we are discussing here today.
So you have heard our ambitious goal that by 2050, we want to become carbon neutral. When we say we, it means the complete industry, which we're talking here about. And that is not achieved by waiting until 2049 and then do a radical shift over. This can only be achieved if we start now with the many pre-preparation stages, which we can do now, but also by having already in the mid to short term period to have goals what we can achieve, because carbon neutrality in 2050 means a steep reduction by 2030, means by 2050 2025 we have to have new technology into place which can enable us to achieve that. And now comes the question, what can the FIWARE ecosystem contribute to this? What can the FIWARE ecosystem, who is already contributing to the overall European data strategy, what can the FIWARE ecosystem, especially in the smart industry area, contribute to this twin transition of the complete European industry? We said it needs to become greener. We said it needs to become more digitalized. What we are asking us from the Smart Industry Mission Support Committee is, what is the role of these open source frameworks, and what are the solutions which we can offer as part of the FIWARE community for this twin transition and for the manufacturing industry? what are the new technology trends that we need to adopt? Because, you know, as FIWARE, we have been around for over 10 years, from the beginning when it was planned until it was implemented and now being used. But as part of that, we need to evolve. And one of the goals of the Smart Industry Mission Support Committee is to identify what technologies to focus on and what should we bring into the technology mix and into our open source ecosystem. Of course, we are learning from existing systems, so embryonic industrial cases which are using some of these new technologies, which are using open source and FIWARE. Is always interest to educate others what can be achieved, to learn from it, and from that to make it even better. So this exchange in the community of what is working, what need to be improved, where is technology missing, that's something that we would like and that we are doing in the Smart Industry Mission Support Committee. And FIWARE, with its technology, you will see that is evolving. We have just issued version 8 of the platform, but with version 8, we already have the first component which announced changes for 8.1 and new things which we are needing to have for the later versions here. And now, from our point of view, we like to look at what we are doing for the smart industry. Next, please. And here's the value proposition. So the value which we are targeting for the smart industry is here, that we want to have this curated OSS system. Curated means we can rely on it. Somebody has checked it before, somebody has pre-integrated all the components into a working system, has tested it, has ensured that we have high quality component, and that we can provide these ecosystems of harmonized components, that we are linking this to standards, the NGS-ILD standard in the core of it, but also industry standards, being it the administrative SS, the SS administrative shell or others part that we need to look into. And we want to overall build this shared ecosystem together with the political and technical support. So that's the value proposition that from FIWARE, from the Smart Industry Mission Support Committee, we are proposing, we are promising to deliver this value. And the advantages which we're giving here, the new technology which we're looking into is that we're considering systems in the future as systems of systems, where a lot of different machines, but also organizations are working together. The data integration capabilities become a major success factors. We learned about the data spaces that are incrementally built, where one of the important aspects is that we can trust in their delivery and their data handling, and that they can deliver us the data that we are needing. And on top of that data spaces, we are building the digital twins, helping us on the twin transition. And the benefits for everybody here is to have cost-effective solutions tested. We have a speed up of the development process, and we can reduce dependencies, and we can increase the reuse by utilizing the platform effect, and we for that can make the developer and the smart industry much more productive than they are today. Next, please. Now, what are the elements of that? I gave you the value proposition, and we're constantly working on that and see what new elements can come into that. But we're also working on the architecture evolution. You know, we have these external companies, other organizations which are looking into smart industry, Industry 4.0, however they are calling it. And we are constantly checking what is in their roadmaps, what is in their architectures. And what we try to identify from that is, first of all, how the FIWARE smart industry architecture should evolve, which technology are missing, what can we do for improving that. Next, please. And we are also doing that not only, and you see here, you see that here already, the industry as it was in the middle of last year. And as we know that technology is evolving, we have started new working groups which should look at new technologies that we're going to add to the architecture. Next, please. You will see that as part of what we call the SIMSC roadmap discussion, meaning the discussion how we are progressing and continuing the FIWARE view as well as the components that we make available. We have, together with the TSC, but also with other mission support committees like the Smart City Mission Support Committee, create working groups on the digital twins, on the data spaces. There are activities on how to use AI and ML. And we want to accelerate the edge discussion because, as we have already learned, edge is going to be a very important technology in all of these areas. And in these working groups, as they are typically across mission support committees, we are going to look especially in the industry aspect. Next, please. We are working here also internationally with partners like the Data Trading Alliance from Japan, the Digital Arabia Network, Industry 4.0, the OPC Foundation, Gaia-X, and others. And next, please. We will see that we want to increase these collaborations with new bodies. Gaia-X was mentioned. There's a new initiative, the Digital Society Initiative in Japan. India is pushing very hard for digital solutions and these kind of things. And the Smart Industry Mission Support Committee is looking at this international collaboration, extending it. Next. For you, you find also success stories. Success stories which shows the impact, and you can look at them and these other things here. And building on that success story and learning from what we have defined, we are defining the roadmap which we like to work on in this year. And with that, I hand over and hand back to Angelo for presenting our roadmap and then leading over to the rest of the presentation, which gives you some of the mentioned success stories and explain you how some technology has been already started investigating, which is helping us for our working groups.
Yeah, exactly. Thanks, Ernö. The roadmap, as you can see, I mean, it's mainly intended to provide the sound basis to develop the technology that has been mentioned as the main challenges that we are trying to tackle within the smart industry domain. So the digital twin, especially at the edge, the robotics, and then the building and nurturing of manufacturing data spaces. As mentioned, these are the three main elements that also we are going to see active and already deployed in some use cases that will be presented in a while. And all of this experience and also the new advanced in the technologies will be, by the end of this year, also collected in a new white paper, position paper from our group that will try to provide these highlights also to a wider audience. And to conclude, I want also to mention which are the main advantage of being part of this thrilling community. So obviously, all the advantage of being part of an open source development community is where you can really get the value of being part of the world, since, as mentioned, the sum is larger than the parts. So please join our mailing list, our communication platform, and try to learn more on what we are doing. So I will stop here, and I will hand over to Cheng from NEC Labs Europe again. He's a senior researcher and is mainly involved in the development of FogFlow, and will present how this can be used also to cross the data silos and allow the data sharing at the edge.
Thanks, Angelo. Yeah, it's really my pleasure to present our recent work on this topic. So today, I'm going to present you or brief you what we have been doing with FogFlow to support this type of twin-oriented data sharing, especially for the case of crossing different data silos. I hope the slides is still visible to you. Somehow was not very clear. So here's the agenda for my talk. I will start with some rough background in terms of this topic, why we are proposing to use digital twin as an approach to sharing data, and also mention some of the challenging issues and give some kind of a quick introduction how we addressing some of the issues with FogFlow. So to start, so I think we are kind of see two type of backgrounds. The first part, we see the main problem with this data silos. This can happen within just one factory. You have a different system which can connect to different sensors or actuators, but they may come from different device manufacturers. And also, they want to talk to each other or sharing information. And this also can happen for this cross-factory communication. Right now, this data sharing is somehow ad hoc. If we can unify the way to sharing the data, that will be our desired feature. And on the other hand, we see this trend of digital twin. Conceptually, that's really provides a very good abstraction because we can then model every physical device as a digital twin. So the digital twin can help us for doing not for interaction. So what I'm going to present is kind of for using this digital twin as kind of for object for the sharing of the data across different domains. So as you can see from this diagram, that as you see in the center, we like to have some kind of created digital twins as this representation for your physical devices, and that can be easily shared across different systems. This is a kind of a system approach, but it really provides a good benefit for sharing data and also for providing a way to access this live data across different systems. We try to follow two types of principles under this type of design. First is to provide unification across different data silos. So we can have this easy way to talk to the other silos based on the same kind of protocol or data formats. I think in this case, NGSI LD is one of the good protocol to be applied. On the other hand, we also try to keep this complexity to be happened only inside the domain, so we can kind of reduce the complexity when we come to sharing data cross domain. These are two principles we try to follow. And there are a bunch of open issues to realize such vision. Of course, here is not supposed to be a full list of all the issues, but today I'd like to mention just three of them. The first one is I would like to introduce our kind of thinking of how to abstractly model a digital twin, mainly for the purpose of sharing and data, and also enable this interaction between different silos. Secondly, how we can kind of create those digital twins from scratch based on our original data. And lastly, there's also a need to control how data will be used in cross different domains. This is a many topic about data governance and data sovereignty. I will narrow this kind of big topic into some of the techniques that we have been explored. You can see in the next slides. So we maybe here. So but we right now extending this open source FogFlow version, which is mainly designed for edge computing, but we also see it fits very well to this cross-domain data sharing. We can use FogFlow instance as kind of edge to be a service orchestrator inside of each of these data silos. And the extensions include three main perspectives. First one is the modeling of the digital twin. We introduced this type of atomic service concept. And secondly, we introduce how we can orchestrate those services around the digital twin in a scalable way and also reliable way. Lastly, we also introduce some mechanisms to ensure the data usage when data is flowing from one silo to another silo. Due to the time, I wouldn't go into the detail, but I like to just brief you what we have been achieved for three of these kind of subtopics. For the modeling, as you can see here as an example, I think easily we can represent a physical device as some kind of entity. This is the digital representation, but beyond that, we also like to model some of the behavior around the digital twin. We try to cover basically three types of behavior. The first one is called this synchronization service. So these three types of behaviors will be covered, will be represented as 3 different types of atomic service. Centralization service, this happens usually in between the digital representation and the physical devices. It's mainly to ensure that the information you extract from the device can be reflected into the digital twin. And if the twin receives some commands or have some change of the state, this can be reflected back to the physical devices as well. This will be in charge by this centralization service. For different devices, you may need different type of implementation for this service. And then there's another type of service called the internal service. This is mainly about how we can take some initial state of the digital twin to derive some further information. The logic of this internal service can be based on some AI or machine learning. And the last one is external service. This is mainly designed for the communication across different twins. For updating some of the status of the digital twin, you may not only rely the information from your own device, but you may need some context information from another twin. In this case, this external service will play a role to get this external information from another digital twin. By having this type of atomic service around each of the digital twin, we can provide a unified interface for applications. So take NGSI-LD as an example, you can just using NGSI-LD to query or subscribe the information from the digital twin. In the meantime, that may trigger some of the necessary service to be orchestrated to produce the information you need from the twin. That is the idea of having this type of concept based on atomic service. Some quick example you can see here for the parking. I think this picture explained by itself. We have 3 different system silos and car and this kind of a gate control at the parking house and some camera. When the car approaching the gates, the car camera can be used to detect the car plates and then to do some authorization, then later control the gates to open. So all of this interaction between different these 3 devices, they can happen in the background across different system silos that can be done on behalf of their digital twin objects. And we try to model each of these devices as a digital twin, and then you see some kind of interaction flow happens across digital twins while this type of atomic service. And FogFlow will help to understand your template, how you implement your service, and also help, more importantly, to orchestrate those services on the fly, creating the digital twin, digital twin entities, and also establish the service flow, this data flow across different services. Yes, so to manage the service, there's necessary to decentralize the controls. That is what we mean by this atomic service. So each silo can have an instance of FogFlow, and each of these FogFlow instance can make its own decision which service to be orchestrated, which digital twin to be created when the physical device joins the system. And we try to decentralize this type of orchestration decisions to be happened directly inside the domain. This can help to improve the performance, also scalability and reliability. And the last part we do is to introduce this type of usage control policy. So from the data or device owner perspective, you can kind of specify how you would like the other DigiTwin or application to use the data associated with the DigiTwin from different perspectives, who and for doing what, and also the purpose for some limited amount of time. So we introduced this type of usage control policy that is supported by FogFlow. And this enforcement can help across multiple silos in a collaborative way. And the detail of this kind of mechanism, we have already published this paper. If you like, you can refer to that. The last part, just to show you one example of this. For example, we consider this automotive use case. We have already implemented 3 types of data usage control. The first one is to fence data, which means data can be only used inside your domain. Anonymization before usage, data need to be anonymized before you can use in another domain. And also time to leave means after use, the data need to be deleted after a certain time. So we support a set of usage control policy based on our internal operator. This can help and can be enforced by FogFlow during the runtime and to provide kind of usage control in a proactive way. To summarize, the talk. So here we are still at the beginning of this journey, and we have already implemented a bunch of features. For example, this concept of DigiTwin together with 3 types of atomic service, and we also improve this orchestration mechanism to have this decentralized atomic service orchestration. We published some paper to introduce how we can enforce data usage control for this cross-domain data usage. And for the further detail, you can contact us, or you can also refer to some of these issues or documents we published with our 2 open source GEs, FIWARE, FogFlow, and also Scorpio broker. So these 2 are the core components we use to realize such framework. That is that closed my talk. Thanks. Back to you, Angelo.
Thanks, Bin. Really interesting also this use case. Now we can move to Ralf Dequeker, that is the CEO of Optidrive, 24 years old company working producing products for sound processing. And he will drive us through a use case where the robotics come to play and how this can be supported by the technology provided by FIWARE. Ralf, the floor is yours.
Thank you very much for the introduction. My presentation has the title From Job Shop Towards Smart Factory. It is about robotics and FIWARE in action. I will first introduce my company, explain what we are doing. Then I explain technology transfer experiment. This presentation is about a technology transfer experiment. I explain what I mean with job shop, what I mean with smart factory. At the end of my presentation, I will show you a video with the success story where we explain what the success of this experiment was. And also I will explain that the outcome of this experiment is a connectivity kit for KUKA robots. It's open source, available for everyone. First, look into what Optidrive is doing. My company brings robot solutions for stone processing companies. Stone processing companies is the first thing I will explain. Natural stone is extracted from the earth in quarries, and finally the products are used for wall cladding, tiles, kitchen worktops, etc. And the stone processing companies makes from a brute stone to these products with different kinds of machines. Here we have a cutting machine, the laser cutting machine, or CNC machines. But finally, there is a lot of manual labor involved also. My company brings robot automation into this environment. For example, here we have a robot for edge finishing of a stone slab. Here we have a robot for tending CNC machines, bringing the products in and out of CNC machines. The technology transfer experiment we did is within the framework of digital innovation networks. We participated here with the experiment, technology transfer experiment. Basically, the technology transfer experiment is about testing FIWARE components in real industrial environment, specifically for us with robotics involved. This is the situation before the experiment. The manufacturing company is organized as with the job shop philosophy, meaning that they have several workstations, several production centers doing a lot of operations. For example, here on the left-hand side, we have a cutting line, a bridge saw cutting the stones to size, and a robot unloading the stones to pallets. The pallets with stones are moved around the factory to the other job shops, to the other production centers. For example, somewhere there is a robot cell for edge finishing. Edge finishing or other finishing operations, chamfer, drill, polish, cut is all possible with this robot cell. And the stones are moved around the factory just with the FIFO system. So first in, first out, the stones are waiting to be processed by a certain production cell. The information flow is top down or is in one direction. So the production cells receive information from the ERP system, but there is no information going back. And there is also no information from one production center towards another production center. That was not existing. This is a typical situation in manufacturing companies. Within the technology transfer experiment, we transformed this towards smart factory concept. We introduced the FIWARE components, the context broker in the middle with the data, containing data, communicating with the ERP database. The robots are bidirectional connected with the context broker. And we introduced several smart services. Very straightforward, a monitoring service, a dashboard to see what's happening in the production. Our client was very interested in this smart service. It's a manufacturability check. This check will verify whether a stone can be produced or can be processed by this finishing operation cell. Is it possible to do this stone with a certain size and a certain combination of required finishes? Is it possible to do this with this robot? You have to know that a robot is non-linear, has a non-linear behavior, and it's difficult to predict whether a certain size with a certain combination of operations is possible with this robot. This smart service will check that. This check can vary in time. For example, a drilling tool is not available for the moment because it's broken. Well, then this smart service check will, for this time being, say that this stone cannot be done by this robot cell. Later on, maybe it's fixed, and then it's possible. Then another smart service is that the logistic, the path or the flow of the material done with the QRM logic, quick response manufacturing logic. It's also a smart service. And for the operator on the manufacturing floor, it's very easy to verify. He takes his smartphone, checks a barcode, and immediately sees the priority of this pallet, where the pallet has to go. Without stress, rush orders can be done. So this is all the concept of a smart factory. At the end of my presentation, we will show you the video where the success of the experiment is explained. Before that, I will finish my slideshow and explain that the outcome of the experiment, we made a connectivity kit for KUKA robots. So with this, it's open source available from this website. And it is a connectivity kit that with tutorials and with easy explained how you can connect KUKA robots to the context broker. And if you do that, you have access to all other applications in the RAMP marketplace to do to make a dashboard and other interesting things. So now I ask Tonya, can you start the video? Hello.
René Natuursteen is a natural stone processing company located in Belgium. We produce high-end made-to-measure products like wall coverings, windowsills and kitchen tops using a lot of CNC work tool machines. The challenge for René is to produce high-end quality components in a very agile way and on a competitive price level. In other words, we need to be able to have a short turnover time and at the same time make sure our products are of the highest possible quality.
Optidrive is a robot integrator. In this project, we integrated 2 robot cells in a smart factory concept. We did this by connecting the robot cells with a cloud database. We used the FIWARE standard and a Grafana component from the ramp. In this context, we developed 2 smart services, the manufacturability check and the quick response manufacturing service.
There are 2 dashboards, one for the robotic cells, one for the pallets. All dashboards can be accessed from any device and also by scanning a QR code. Here's a dashboard for the robotic cell. Everything is green, so everything is fine. When there's a red screen, the dashboard will indicate the correct error so that I can organize the correct intervention.
This is the dashboard of the pallets. It shows the information of the stones loaded on the pallet and the information coming from the smart services. During this project, we discovered the FIWARE standard and the Grafana components from ramp. We hope these become the EU standard for digital manufacturing. Starting from today, our robot solutions will be compatible with it.
We are very satisfied with the results of this EU project. Quick response manufacturing together with the Grafana dashboards mean a major step forward for us in efficiency and cost saving. The manufacturability service is a major step forward for us and a huge cost saver.
Okay, thanks, Rafael. Really interesting also the video, thanks. Now I have to hand over to Professor Paolo Nesi, that is coordinator of the Snap for City project from the University of Florence, and I will introduce on this platform, Snap for City, that a FIWARE-based platform for industry and city integration. Paolo, the floor is yours.
Thank you, Angelo. I am starting to present what we have done in exploiting FIWARE in the Snap for City platform, which is a platform of FIWARE. And so the case was in the Altair chemical plant with the aims of establishing and creating a control room with a high-level supervision and monitoring. So we have in place this solution since the 2020 for management of the production plan optimization and to control the perimeter of the plant with the drones and sensors. In addition, we have since the 2017 the maintenance monitoring and ticketing, and we are putting in place in this period a mechanism for predictive maintenance and also for 3D digital twin connected to the predictive maintenance. So the general schema is represented in these slides, in which we integrate OPCI UA and Modbus from the field, and also from administrative database.
Sorry, Paolo, you are not sharing the screen.
I am not sharing? Oh.
No, or I have some issue on my side, I don't know.
Sorry. I can return back a little bit. Now?
Yeah, now it's fine, yeah.
Now it's fine. Sorry again. So I am presenting the Snap-on City, Snap-on Industry, as we have used, exploited the FIWARE-based platform for industry city integration. So the the scenarios is that of Altair chemical plant that you see here in the slides. The goals was to set up the control room for high-level supervision and monitoring. It is operative since 2020 with the management of the production plan, optimization, and also to control the perimeter with drones and sensors. Since the 2017, we are also managing for them the ticketing for maintenance. We are adding predictive maintenance and 3D digital twin in connection with the maintenance and monitoring of the data sensors. So the architecture is represented in these slides. This is a functional architecture based on microservices that exploit the FIWARE component Orion broker. And so we collect OPCI, UA, and Modbus data from the field, and also from administrative servers, the information regarding to the new product and business to be produced by the plan. So also the energy is also a cost to be taken into account, and some sensors arrive from drones for monitoring the perimeter through a LoRa gateway that push out to NGSI Orion broker. So inside we have storage, obviously, and support for digital twin and maintenance, and also data analytics for predicting maintenance and production plan optimization. For the front end, we use the dashboard builder, Snap-on City dashboard builder, to show us a larger set of dashboard and synoptics and 3D, and also Kibana for the open distro for the maintenance intelligence tools. So this is one of the first plant that we have done, exploiting the Snap-on City solution that is powered by FIWARE, GDPR compliant, fully open source, that collect any kind of data and integrate also data flow and workflow in the mechanism, not only something to dashboard or something to data analytics, but also an integrated manner to manage data flow and workflow. I am going to see more in deep how it works, to show you how it works. So the Orion content broker is central part of the data gathering. All the data coming from the field and from the administration, and also from the device and the drones and so on, arrive in the storage passing through the Orion content brokers. Also, we have some IoT application which are Node-RED, and they are installed on the edge for data transformation, but also these IoT edge produce messages in NGSI through the Orion brokers, and also exploit other microservices of the infrastructure. Also, the data analytics are containers that are scheduled and managed by Node-RED and IoT apps, and also produce the data and results, pushing the data through the Orion brokers in the storage. So the architecture has a number of containers with the IoT apps, also for the business logic of the several dashboard, and also for managing data analytics, and in the IoT app with an uniform programming language, which is the Node-RED, as you see here in the slides, in which you can create a data-driven process, data analytics, exploit the Smart City API, exploit business logic in the dashboard, govern the workflow in digital twin, manage all the process, include the scheduling. There is a large library of Snap4City microservices on Node-RED that you can download and install in any Node-RED. And there is also a large set of NGSI elements on which you can interact with the brokers to storage, save, retrieve the data, and also to interact with the devices. So what you obtain are dashboards, several kinds, with trends, maps, and also synoptics, with an end-to-end secure communication, with the WebSockets secure and also HTTPS secure. And in addition, we added a local digital twin. So we had already developed something for showing 3Ds in the maps and so on. But recently, we added also the possibilities to navigate in the plant, to have the real-time data, and to integrate this information in the dashboard so that you can pass from the global to local digital twin, and from the actual data recovered from the storage, exactly attached to the elements in the 3D. In this way, when you have problems, when the maintenance detect the problems, or the predictive maintenance predict some problems, it's also possible to see exactly which is the area or the possible devices that could be replaced and where they are located with the navigation in the 3D shape. So, as you have seen, Orion Context Broker is central in the Snap4City, Snap4Industry solution. Orion enabled the interoperability and the ingestion of data coming from the field with the robots, sensor, actuator, drones, and so on, but also with the control system, distributed control system, SCADA. And most of the data are also transformed on IoT Edge by using the Node-RED with the library of Snap4City. And they are both adopted in the IoT Edge on cloud. And you can also have some business logic to govern the logic behind the dashboard, and exploiting data analytics. It is also another aspect. So what we have at hand, the infrastructure and the solution. Presently, it is used in a number of industry installation, all of them exploiting Orion Context Broker, in all cases, on both on-premise or on cloud. So some of them are directly on-premise of the company, because this is a mandatory in most cases for industry case. And it's also possible to make online development with the low or no coding, part for the data analytics. But all the rest is a very low code needed to create the solution. For this reason, we think that is an easy way to develop a smart and complex solution with a large interoperability, exploiting the component of FIWARE, but also the capability of Node-RED, and the dashboard with the synoptics and visual analytics, and also Kibana, which is a sister of Grafana in the open distro, is very powerful. And we have a uniform visual language for all the phonetics that you can need for data transformation, integration, and so on. And data analytics is mainly performed in Python and RStudio, that are transformed directly in containers that we manage in the cloud, or in a small installation around and deployed directly in the plant, because in most cases the industry would like to have their own installation on premise. I think I finish. One note: if you would like to know more, you can about the platform. You can have some slides here from this link. And I would like to say thanks to have spent your time to listen us. Thank you.
Okay, thanks, Professor Nesi. Now we are moving somehow out of the factory, but also looking at some other kind of scenario with Fabio Floreani, that is the CTO of the Consorzio Intellimech, that is going to show the use case, a really interesting use case from Brazil, with the decentralized manufacturing and robotics and additive manufacturing together. So, Fabio, the floor is yours.
Yes, thank you, Angelo, and thank for inviting me to present during this session. As Angelo said, the presentation is focused on a specific use case that was developed during a European project. The use case was developed in Brazil because the project, one of the strategic object of the project was to promote the collaboration of Europe with Brazil, and specifically to exploit mainly standard and open IoT architecture from Europe to Brazil. For example, of course, FIWARE. And from a technical perspective, instead, the topics are mainly three: to integrate the robotics, additive manufacturing, and IoT technologies; to create a tool for optimize, synchronize, and improve the real-time coordination of production, specifically to enable flexible production and one-piece production paradigm. And last but not least, to validate all the technical aspects in two pilots. One for Embraer, so in the aerospace industry, and the other one for manufacturing with the Thyssen Krupp. What I'm going to present you is the second one, so what was developed for Thyssen Krupp, and especially for the lift division. Okay, the problem to solve here is mainly the fact are different. One is related with the communication between, in Brazil here, between the back office and the manufacturing area. And so the idea here is to use the IoT platform in order to enable this communication. Another topic is that more than the 70% of the elevators demands one of a kind spare parts. So conceptually, having a unique warehouse for the spare parts is inefficiency in terms of cost effective. And so the idea here is to use additive manufacturing in order to produce the spare parts when it is needed. Last but not least, Brazil is a very big country, and so the cost of delivery and time of spare parts is too much, especially because the infrastructure are often not well developed. And here the idea is to use a predictive real-time optimization and simulation tool in order to allocate the production in a specific distributed cell in the country. What I mean for cell, these are the cells. So the idea is to create different cells in Brazil. These cells are called SRAM, so Smart Robotic Additive Manufacturing Cell. They could be different, but mainly there is the presence of a robot, an AGV, and a 3D printer. So the 3D printer received the order for produce a specific spare part. The robot take the piece. The robot place the piece on AGV, and the AGV then deliver the piece first to the little warehouse nearby the cell, and then from the cell the delivery can begin, and deliver the component to the to where the failure occurred. So they said there are different cells, and the idea is to allocate to distribute them in the more optimized situation as possible. And this allocation was done using a specific simulation and optimization tool in order to cover the major part of Brazil, take into account different constraints, for example, the presence of infrastructures, and for example, the number of elevators in that specific part of the country. Okay. So they say the idea is to promote the diffusion of open IoT platforms. So overall in the project, and specifically in this case in Brazil, double perspectives was carried on. So the use of FIWARE and the use of Apache, and test the interoperability between them. This is more or less the concept of the project. So in the bottom part, there are the SRAM units. All the units communicate through an IoT platform, so with the higher level, so mainly the legacy system of Thyssen, an optimizator tool, and the real-time monitoring and performance management tool. So mainly here, there is a part of real-time monitoring of the cells. As I said, it was developed a hybrid infrastructure, which is composed both with FIWARE and both with Apache. On the left part of the slide, so in blue, there are the FIWARE lanes, which is mainly related with the real-time monitoring and presenting on the information of all the cells in Brazil. So there is a FIROS interface that was developed to communicate with the robot and with the 3D printer, the Orion broker, CreditDB, and then Grafana dashboard to present real-time data from the SRAM. In red, on the right part, you can see the Apache Kafka lane. Here there is the APM, which is mainly a container of all the information and resources of the cell. And this block also enable a digital twin representation of the cell. And then using this lane, there is not only the possibility to view the digital twin while the real system is running, but also it's possible to communicate with the module that was developed during the project. So the Ultimate Simulator and Optimization tool, and also the communication with the enterprise system. So entering more in deep in the left part, this is more or less the situation. So this is an example from a university in Brazil. Here we have the AGV. On the other part, we have the manipulator and the additive manufacturing machine. Here on the right part, we have the digital twin of the plant. Okay, and also it is possible to see, changing the interface, the real-time dashboard using the FIWARE lane of all the parameters that are getting from the field. So, for example, the duration of the printing activity, the time left for finish the additive manufacturing activity, so the spare part printing. And on the bottom side, there is all the instrument that manage the information around the cell, and so give the information, for example, about the production and the scheduling of the production. On the right part, we have as I said, the Apache Kafka lane. The Apache Kafka lane, as I said, is more related with not data in motion part, but data at rest. And so mainly the idea is that the maintenance operator communicate with the legacy system, with the ERP of Thyssen Krupp, asking for a specific spare part. The production manager use the holistic and simulator tool in order to get the right SRAM to produce the specific spare part. This logic is according, for example, using the availability of each SRAM cell and using the nearest SRAM cell to the location where the spare part is required. And then the production manager could trigger the SRAM operation, and then the cell autonomously produce the spare part. All this information are managed using the Apache and Kafka lane. As I said, one of the objectives of the project is to promote the diffusion of the FIWARE and Apache lane in Brazil and also in Europe. These are all the locations where FIWARE and Apache were tested. All these locations are not only specific of industry, so of Embraer and ThyssenKrupp, but are all installations also in academia and research center. The feedback from Brazil about FIWARE was very good. They said us that it is a great tool to enable a fast proof of concept of an IoT architecture in general. And this is the last slide of my presentation. Thank you, Angelo.
Okay, thanks, Fabio. Now is really running a bit out of time, and we have the last use case from Luis Usatorre, project manager at TECNALIA, and he will present us data sovereignty and embryonic data space for the metal domain coming from the Market 4.0 project.
Yeah, I hope you can see my slides.
Yes.
Very well. Good morning, everybody. Thanks, the organizers for inviting me to do this presentation. I will talk about Market 4.0, which is a project trying to promote the marketing of manufacturing equipment and of manufacturing services. I cannot see my screen anymore. I see your picture, Angelo.
Yes, you can. You have to start again the presentation.
Yeah.
Something's happened. Okay.
Can you see? All right. So all right. So the idea is the reason for this marketplace is that the equipment purchasing is moving towards Asia, towards China, Japan, Indonesia, Taiwan, etc. So European manufacturers will need to address those markets. The European market is growing smaller, and one of the options, of course, is a digital marketplace, and this is what Market 4.0 is trying to promote. I will address here in this presentation not specifically the vertical digital flow that, of course, is here in the project, but the horizontal digital flow amongst the different companies. In the manufacturing sector, there are very many different domains: the plastic domain, the metal domain, electronic equipment, high-tech equipment. And looking at the metal domain in particular, there are lots of different manufacturing processes: machining, milling, bending, drilling, cutting, additive manufacturing, and many more. The idea is it is difficult to make a marketplace for all these different domains and all these different manufacturing processes. Our approach is that well, in the left-hand side, we have a customer that wants to purchase an equipment. On the right-hand side, we have equipment providers, not only one, but many of them. And the customer has to take this journey in order to define what is the equipment he requires. He has to look at very many different types of equipment. And what we have to try to do is to help the customer contact with the equipment provider, providing services that can help his decision making. Of course, first of all, in the left-hand side, we have an equipment selection, depending on the manufacturing process, depending on the part size he wants to produce, depending on the material he wants to use. Is not the same stainless steel or titanium. So he can do a browsing and a pre-selection of the equipment. Then there is a second set of services dealing with equipment productivity, analyzing the characteristics of that pre-selected equipment. Of course, there are different services for the different manufacturing processes. It's not the same if you are analyzing a laser cutting machine or an additive manufacturing machine or a bending machine, etc., etc. After that, the customer usually wants to have certain product service systems, certain services implied in his equipment, and we have another service that helps on that. And at the end, we have services that can help in the interconnection of that equipment with the existing IT infrastructure of the company. This process that usually takes the customer 1 year to run or to take. The idea is that Market 4.0 helps him to do this shorter and seamlessly and more comfortably. Of course, we are not addressing here all the different manufacturing processes. That is why there are open calls and new manufacturing processes are being addressed. And new ones will come later. So new services will be implemented. The idea here is, as somebody said before, is a distributed cloud of services, according to the European data strategy. I think Mr. Kovacs said that before. Okay, and we are based on the IDS reference architecture. I think you are aware of it. I will not go into the details. It's based on the IDS connector, a generic enabler in itself. And we have here in blue the Market 4.0 platform, in green the IDS different connectors and modules, and we can see also the different stakeholders, the equipment manufacturers, the customer, the service providers, and all integrated within this IDS architecture. This is the IDS reference architecture. Some details about the connectors and some details about the rest of the modules. We are using here open source connectors configured specifically for this horizontal service of connecting customers and suppliers. And what we can see here is our initial approach. Our idea was, as Yves and Paindaveine said previously, start small and scale fast. So we started. In the right-hand side here, we have the customer that wants to select an equipment. On the left-hand side, we have the different equipment providers. We started with Prima, which is an Italian manufacturer, and Prima has his repository here in green color. And on the right-hand side, we have the equipment selection service that will select the machine that according to the customer needs. We have IDS connectors in both sides, in the data provider and data consumer. Those IDS connectors were open source TNO and engineering connectors configured by TECNALIA. And we have in the center, in Market 4.0, in the central platform, certain IDS modules, clearinghouse, a broker, identity provider, etc., that do the data governance of the data transaction.
Luis, I'm sorry for interrupt you, but we are really too close since the next session is going to start.
Right.
Yeah,
so
I know that you were there.
This is how it ended. It's a rich pool of data now with different sectors, different countries, respecting the GDPR and, well, according to interoperability standards. So now it's a proper data space in itself. Yeah, thank you very much. That's it.
Thanks, and sorry again. Okay, so thanks you to all the speakers. Now it's turn of also having Tonia from FIWARE Foundation on the stage. Tonia, for the final remarks. Tonia, are you there? Tonia, we cannot hear you. Okay, so I think that we have to conclude now. In any case, the chat will remain available. So for any further question, do not hesitate to contact us. And please follow also the rest of the programs. And again, really thanks to you all. See you. Bye-bye.